Hello everyone. Today we have an important topic to learn about Android architecture. Whether you are a developer or an Android enthusiast or just curious about how your smartphone works, this video is for you. So, what is Android? Android is a multi-purpose and open source operating system primarily designed for mobile devices. Nowadays, it also plays a major role in automotive infotainment systems. It offers a flexible architecture that supports various types of applications, including Android apps, privileged apps, and device manufacturer apps. Because of this flexibility and customizability, many car manufacturers prefer Android over other operating systems. Let's get deep dive into all the layers of Android operating system. The first layer, application layer. The second one, application frameworks. The third, native or platform libraries and Android runtime. The fourth layer, hardware abstraction layer. And the last one, which is the foundation for the Android operating system, it's Linux kernel. Linux kernel. The Linux kernel is the foundation layer at the bottom of the Android architecture. It manages all the drivers such as display driver, camera driver, Bluetooth driver, audio driver, etc., which are primarily required for Android devices during runtime. The kernel is the central component of any operating system responsible for communicating and controlling the underlying hardware. The AOSP kernel is structured with both hardware agnostic modules and vendor specific modules, making it more adaptable to different device configurations. The Linux kernel provides an abstraction layer between the device hardware and the rest of the stack. It is responsible for memory management, power management, device management, resource access, and more. Let's move on to the next layer, the hardware abstraction layer. The hardware abstraction layer provides a standardized interface for hardware vendors to implement device-specific functionality. HALs allow Android to remain hidden about what lower-level driver implementations are, ensuring compatibility with various hardware configurations without modifying the core system. HAL's main benefit is that it encapsulates diverse vendor implementation and offers uniform API for top levels. Different hardware combinations may be available from different manufacturers. They may support same feature in several ways. For example, cameras. Hardware vendors use HAL and Android is unaware of their internals. In general, Android HAL connects the hardware and software. These are about hardware abstraction layer. The next layer, native or platform libraries. This layer provides essential functions to operating system and applications. The platform libraries include various C++ core libraries and Java-based libraries such as Surface Flinger, OpenGL, SQLite, WebKit, Media Framework, libc, FreeType, and more. Let's see each of these libraries in detail. Surface Flinger. The Surface Flinger library provides the display management, which is responsible for rendering views in the screen. OpenGL. OpenGL is a library for 2D and 3D graphics support. SQLite. It is a database support for Android operating system, where the data are stored in tables. WebKit. It is for browser support like Chrome, Mozilla, and so on. Media Framework. It is responsible for playing and recording audio and video formats. FreeType. It is for font support. libc is a specially designed library which is C library for Android. And there are more native platform libraries inside Android. The next layer is Android runtime. The Android runtime is responsible for executing and managing application code. In older versions of Android, the Dalvik virtual machine was used. However, since Android 5.0, Arch became the default runtime. Arch uses ahead of time compilation, which improves application performance and reduces power consumption. It compiles application code into machine code when the app is installed rather than interpreting at runtime. Android Runtime is a Java runtime environment provided by Android open source project. Arch translates apps bytecode into processor-specific instructions that are executed by the device's runtime, which will then further improving app's performance. On top of native libraries and Android runtime, you will find the Android framework. It provides numerous classes and interfaces for Android application development. The Android framework consists of Java classes, interfaces, and precompiled code that forms the foundation for building Android apps. While portions of the framework are publicly accessible through Android API, some are restricted and only available to OEMs through system APIs. Android framework code runs within apps process. The Android framework includes Android APIs, which provides various essential services to Android applications. It includes Activity Manager, Package Manager, Resource Manager, Windows Manager, Location Manager, Telephony, Content Provider, and View System. The Activity Manager manages the lifecycle of application and user interfaces. The Content Provider allows data sharing between apps. Location Manager provides location-based services such as GPS data. The Notification Managers handle the notification from all the apps. The Telephony manages the phone and messaging services like SMS, incoming call, dialing, etc. The Resource Manager is responsible for accessing the system resources through the apps. The View System, there is a user interface framework which manages the widgets and layout managers. Application layer. This layer is the topmost layer of the Android architecture. It is where users directly interact with the interface. Here you can find apps like phone, email, calendar, alarm, browser, SMS, settings, and more. In the application layer, the app can be further categorized into three parts: Android app, privileged app, device manufacturer app. An Android app is created using Android API and is available on the platform like Google Play Store for download. These are created by developers like us and are commonly used by Android device users to enhance their mobile experience. Privileged app. Privileged apps are created using combination of Android and system APIs. They are pre-installed on a device and have access to more system level features compared to standard Android apps. Device manufacturer app. These apps are developed using a combination of Android APIs, system APIs, and direct access to the framework implementation. They are pre-installed on the device and are often responsible for providing core functionality to specific device. Typically, they can be updated when the device's system software is updated. In summary, the Android OS architecture comprises multiple layers from the top level application layer down to the hardware layer, each serving a specific purpose in facilitating the development, deployment, and operation of Android devices and apps. This architecture's flexibility and modularity contribute to the widespread adoption and success of the Android ecosystem. If you found this video informative, don't forget to like, share, and subscribe for more tech related content. Thank you for watching, and we'll see you in the next video.